We are back at it, exception handling. A reminder from the previous video, exception handling allows us to terminate our programs gracefully, to handle those errors gracefully. So instead of your program abruptly crashing and, fire around us showing here and we think everything's fine, no, that's not fine. We want to be able to handle those exceptions gracefully. What did we do in the last video? We used try-catch blocks. The try block is where we put that problematic code, a code that would perhaps maybe call a method. That method in turn may potentially cause an exception that then got thrown back to us, such as a library method, and we use the catch block to then handle that exception. What was the main value of exception handling? We said that on using that method example, a method has no right to single-handedly or unilaterally, I mentioned, to determine just to abort the entire program and stop it in its tracks. It has no right to do so. Instead, the method should do what? It should throw an exception back to the caller, whoever called that method, and let that person determine how they would like to best deal with that exception. That's the value. So the key benefit here of exception handling is to separate the detection of an actual error or an exception that occurs from how we handle that error. Because usually the one who detects the error may not be the one who's most appropriate to then handle that error. So now in this video, we're going to cover how to actually declare these exceptions, how we explicitly will throw those exceptions, even rethrow them, where one method handles the exception a little bit, but then determines, you need to handle it as well. So they rethrow it after they catch it. And also we're going to discuss how the exception handler works. So Java's exception handling is really based on three operations: the idea of declaring an exception, throwing an exception, and catching an exception. So you see here we have method 1, we have method 2. Method 1 contains this try-catch block. So when you see a try-catch block, the purpose is, we're going to try some code that may ultimately cause an exception. Whether that exception is caused here locally in this method, or this try block includes a call to some other method that then results in an exception. So the latter is what we see here. In this try block, we are invoking method 2, and in method 2, we have an if statement where inside this if statement, we're throwing an exception. So here we have the declaration. Right here in the header, we're saying that, hey, heads up, or we're warning that this method may actually throw an exception. Sorry, the declaration is here. We're declaring a new exception. We're creating that exception object, and we're throwing it back. But we're also, as part of this method signature, we're declaring that heads up, this method may in fact result in an exception. So whoever calls this method, you have to be prepared to deal with that exception. And then here we throw the exception, and then finally we catch it back in method 1. Every method must state the type of checked exceptions that it has to, or that it may end up throwing. This is known as declaring an exception. So because system errors and runtime errors, they can happen throughout your code, we mentioned that these do not require such a declaration. Java does not require that you declare errors and that you declare runtime exceptions. These are known as those unchecked exceptions. You don't have to explicitly declare them. However, all other exceptions that the method may throw, they must be explicitly declared in the method header. Why? Because think of that method header as a signature, and by explicitly declaring that exception in the method header as a warning that heads up, I may end up throwing an exception, now anyone who calls that method, they have been so forewarned, and they now know, oh, if I call this method, maybe that method will throw an exception, and I now have to deal with that. To declare an exception in a method, we simply use the throws keyword in the method header. So here is a particular method that is possibly going to throw an IO exception. So we say throws IO exception. For clarity, this does not mean that this method, my method, it doesn't mean that it's guaranteed to throw an exception. What it means is that this method may end up throwing this IO exception, and an IO exception is absolutely a checked exception that you have to deal with. And as a result, because this method may end up throwing an IO exception, it absolutely must put this warning in the method header to indicate to any caller that heads up, we may end up throwing an IO exception. Of course, the method can maybe throw multiple exceptions, in which case you would simply list them all out. Throws IO exception, comma, other exception, comma, even some other exception. That's declaring an exception. What about throwing an exception? When the program or that method detects an error and you create an instance of that exception class and then you throw it, that's called throwing the exception. And here's the example. We would make a new exception object. Here I'm calling it some exception. We save an address or the reference of that object into this variable EX, and then we throw it. Or we can just throw it in one line, throw new some exception. We don't need to first save the reference of that exception object into a variable. We could throw it directly. So here we had declaring, here we had throwing that exception. And here's an example. So we had this set radius method that we've seen previously, where clearly we only want to set a radius if the radius is greater or equal to 0. If the radius is less than 0, clearly that's not a valid radius and should never be set. So here we have this setter method. We send over a radius. If the radius is greater or equal to 0, we set that new radius value into radius. Otherwise, with this else, we throw an illegal argument exception. And we just put this parameter in that constructor of this new exception object saying that the radius cannot be negative. So the keyword to declare an exception here is throw. This is where we're declaring, the keyword to create this new exception object is throw, but the keyword in the header to declare that, hey, this method might end up throwing an exception is throws. Make sure we understand and we see that distinction here. Throw is when we're actually creating the new exception object and we're throwing it, and then throws is what goes inside the actual header itself. So we know how to declare the exception. We know how to throw the exception. How do you catch and handle the exception? You use this try-catch block that we saw last time. The difference here is now notice that we have many catches. So inside the try block, we're trying some statements that may potentially lead to an exception being thrown. But what kind of exception could be thrown? Many. So we have to have those same catch blocks that will catch one of the exceptions. And once any one of these catch blocks has found to be true, like we can catch an input mismatch exception, if that's the exception that was thrown, then we ignore all of the subsequent catch blocks. So if what was thrown was a null pointer exception, for example, we will skip this because it doesn't match. We come to this catch block, we will execute the code inside this catch block, and then skip the remaining catch blocks. This is how that sequence actually works. What really has to be discussed now is this idea of an exception handler. The exception handler is the code that deals with the exception. How do we really understand this exception handler? The exception is actually propagated backwards through a chain of method calls starting from the current method. Each catch block is examined in turn from first to last to see if a matching catch block was found that can handle the exception. If we find a matching catch block, perfect. We handle the exception with that catch block and we take care of it. But if no handler was found, if there was no matching catch block, Java will exit that method and will pass the exception back to the method's caller and will continue that same process, looking for a catch block that will be able to handle that exception. And if once again there's no matching catch block, well then that method will be aborted and the exception will in turn be thrown back to its caller. All the way back to if you make it to your main and there's still no catch block, that's when your program will still ultimately crash. So this process of finding that handler that can deal with the exception is called catching an exception. And what follows is a detailed example here on page 41. Follow me, we're going to go through this. We have a main method. That main method is going to call method 1. Method 1 calls method 2. Method 2 ultimately calls method 3, which has an exception. So let's break this down now. The main method, we have a try catch block. We're trying some code that's invoking method 1. If there's an error, an exception that's going to be created and thrown, well, we have a catch block. And of course, we have some statements that are after the try catch block, which you see is the same for each one of these methods. Here we have statement 4. It's just some lines of code, some statements that occur after the try catch block, and the same thing for method 2. So once again, we're in the main method, where we try, in the try block, we invoke method 1. Well, now inside method 1, in its try block, we invoke method 2. In method 2, inside its try block, we invoke method 3. And now we come over here to method 3, and an exception occurs and is thrown back. Where does that exception get thrown back to? Does it get thrown back to main? That doesn't make sense. Because remember, we have this call stack. The main method is open, but then when main calls method 1, the main method is effectively on pause, and method 1 is running. Now when method 1 calls method 2, main is on pause, method 1 is on pause, and method 2 is running, right? That's the top of the call stack. Well, now when method 2 calls method 3, main is paused, method 1 is paused, method 2 is on pause, and method 3 is at the top of the call stack, and it is running. Well, guess what? Method 3 just caused an exception, and that exception is going to get thrown. Where does it get thrown back to? Well, method 3 gets aborted, and it gets thrown back to the method at the top of the call stack, which is method 2. So here we're going to go through many different examples of what kind of exception could have been thrown more generically. So we're going to say, well, what if method 3 throws an exception of type exception 3, which means it would get handled here? Or what if it throws an exception of type exception 2, which means it's going to come to here but ultimately roll back to here? Or what if it throws an exception of type exception 1? We're going to show you how it has to come all the way back. And then finally, we're going to say, well, what if it throws an exception that's not caught by any of those? What ultimately happens? And we're going to break that down for each one of those examples. And so on the next slide, we have these 4 bullet points where it covers each one of those examples. And you can come pause the video, read this, but I'm going to go back to the previous slide just to go through each one by one. So here, what if an exception of type in method 3, it throws an exception of type exception 3. That means method 3 is going to be aborted. And so this invocation caused an exception, which means statement 5 will be skipped, right? Since we're invoking method 3, which caused an exception, that exception gets thrown back. We're going to skip statement 5 as a result, and we come to this catch block. And we process exception 3 because they match. It threw a type exception 3. Well, here we're catching exception 3. We process exception 3. That is fine. We then execute statement 6. Method 2 then ends gracefully. We come back to method 1. We continue with statement 3. Then statement 4, nothing gets caught here because we've already handled the exception. Method 1 closes, and we then continue with statement 1 and then statement 2. Again, no catch happens here because the exception was already handled over here inside method 2. That was if we throw an exception of type exception 3. So it said that it will be caught by the catch block for handling exception 3 in method 2. Statement 5 was skipped, and we go to statement 6. And of course, we then execute statement 3, 4, 1, and 2. Well, what if this exception in method 3, what if what is thrown is an exception of type 2, exception 2? And again, these are just generic names, right? It's just a teaching example. What if we throw an exception of type exception 2? Well, it gets thrown back to here. We invoked method 3 that caused an exception. We come to here. Statement 5 is going to be skipped. And now we try to look for a matching catch block. We don't find a catch block for exception 2. What happens? Statement 6 is going to therefore not even get an opportunity to be executed, because since there is no matching catch block in method 2 to catch exception 2, this entire method is aborted. It's aborted. And that exception gets thrown back to the previous method, and now we're back here at method 1, and we come here, again, this method, the invocation of method 2, is what ultimately then caused an exception down here in method 3. So now the exception gets thrown back all the way to here, and it looks for a matching catch. Thankfully, there's a matching catch to catch exception 2. We process that exception 2, then we execute statement 4. Method 1 terminates normally, it finishes normally, and we go back to our main method. We then execute statement 1 and statement 2. What if this exception, and that's the second bullet point, if you want to pause the video. The third bullet point, what if this exception was of type exception 1 over here in method 3? So we throw exception 1, it comes back here to main method 2, or to method 2. We don't find any exception 1 matching catch statement, catch block. So this method is aborted. We skip statement 5, we skip statement 6. They don't have a chance to run. This method's aborted, and then exception 1 comes to here. Statement 3 is skipped. We come to try to catch exception 1. There's no matching catch. So statement 4 will not have a chance to run. This method will get aborted. We come back now to our main. Statement 1 is going to be skipped because we have an exception when we invoked method 1. And we have finally a matching catch. We have a catch for exception 1, which is what I said just got thrown over here in method 3. We have a matching catch for exception 1. We process exception 1, and then we finally execute statement 2. That is the third bullet point. What's the fourth bullet point? Is let's just say that we throw some exception that's not caught by any of these catch blocks. That exception goes all the way back. At first, let's say we're throwing exception 0, a type exception 0. We come here, there's no exception 0. This method is going to be terminated. It's going to be aborted. Then that exception is thrown back to method 1. There's no matching catch. So we skip statement 5, skip statement 6. Statement 3 and 4 will not get executed. And we're going to have to abort method 1. We come back here to the main method. Statement 1 gets skipped. We come to the catch, trying to see, can we finally catch it? Nope, because it's exception 0. So even this catch doesn't work. Statement 2 is therefore never have a chance to run because now the main method crashes. Because now, where does that exception get thrown? I'm going to pull off my glasses. That exception gets thrown in your face with some red text by the editor, by the IDE, and it throws the exception at you. It's a great example. Here we throw the exception to method 2. Method 2 throws it to method 1. Method 1 throws it back to method main. Main says, well, I don't have a catch, and it throws it at you and says, well, you got to deal with this now. That's the idea of how this works. Last time we did this problem where we had these months, we did this with a do-while loop, and we had a try-catch here just to worry about the index out of bounds, right? So when I put 13, it said that was an invalid index, try again, 0. And then finally, when we enter a valid index, or valid month number 3, it worked perfectly fine, right? This was an example in the previous video. Here we're saying, well, what if the user enters invalid input, right? What if we say enter the month number from 1 to 12, and the genius says, great, I want to enter 3 for March, and they spell it out. Of course, we have errors. That exception was literally thrown back in our face because we did not actually handle that exception. So what can we do now? We want to handle that with an input mismatch exception. So what we can do is simply come here and put another catch. We can put another catch and say catch input mismatch exception. And say you must enter an integer. There you go. Simple as that. I'm going to erase all of this. Oops, I erased way too much. Let's try that again. I want to come to right here. There we go. You must enter an integer with a new line. Let's run this code and see what we get. Let's put in something. And now we're in a constant repeating loop. Pause the video and think about why might you be in this infinite loop? What's actually going wrong here? So what's going wrong is the fact that notice we scanned with a next int. The user entered an invalid input, right? We've then told them as much. And so when we catch this, we tell them you've entered something wrong and it's coming back up here and it's trying to scan again and it's prompting enter a number and it's scanning and that wrong input it's still trying to scan that. So the easy fix is we just type in.nextLine. That would have been a hard one to honestly debug if you haven't seen that. So when I hit stop and I run this again, hit stop, run this again, we're going to see enter a month number. They type in 3. You must enter an integer. Now they type in 3 and we are good to go. So here we have two different exceptions being caught. Let me enter 3. Now let me enter 0, right? We're catching both of those different exceptions. Finally, we enter 11 and we have November for 30 days. Here is a solution. You can pause the video and see perhaps a slightly different solution here. So catch or declare checked exceptions is a question. So Java forces us to deal with checked exceptions. Consider a method that declares a checked exception, such as an IO exception, something other than error or runtime. You must invoke this method in a try-catch block, or you must declare that you're going to throw the exception in the calling method. So that may not have made sense. The example will make sense. Suppose we have some method P2 defined as follows. So here's this method P2, and P2 is saying that, hey, heads up, I am possibly going to be throwing an IO exception. An IO exception is a checked exception. You have to deal with this in Java. So method P2 is saying in its method header, in its contract, you can call me, but warning, be forewarned, I may throw an IO exception, which you have to deal with. So the question is, how do we deal with it? Well, here you are. Imagine your method P1. You have one of two choices. You can either say, well, I'm going to deal with that via a try-catch block. I'm going to try to call P2, and if P2 does in fact throw that IO exception, well, I'm going to catch it here and I'm going to deal with it. That would be one way of dealing with it. Or you could deal with it this way. You could say, you know what? I'm just going to call P2 outright. And if P2 throws an exception, well, that's above P2's pay grade. And then you're going to say, it's actually above my pay grade as well. So I'm not even going to deal with it myself. I'm just going to in turn throw it also. This is the hot potato example, right? So here we're dealing with it. But in this example, if you're P1 and you call P2, and remember, P2 is maybe going to throw this checked exception. Here you're saying, yeah, but I'm not going to deal with it with this try-catch over here. Instead, you're saying, I'm just going to throw it to whoever called me. Both of these are valid. It's not that one's wrong, one is right. Here you're catching that exception and you're dealing with it. Here you're saying, well, I'm not going to deal with it. I'm going to throw it to whoever called me, hot potato, let them deal with it. But we have to, one way or the other, we have to handle it, either by taking care of it ourselves or by passing the buck, the hot potato analogy, and passing that exception back to whoever called us. Order matters. The order in which exceptions are specified in the catch block is important. So because we can mention many exceptions in this series of catch blocks, you want to go from the more specific exceptions first to the more general exceptions afterwards, right? So if you have noticed, as we've seen this exception class, there are subclasses, and then within those subclasses, you don't want to mention the superclass first. Like if you say here, catch exception, which will catch everything, but then underneath you say, oh, we'll catch this specific exception, well, that will cause an error, and it doesn't even make sense. If I come over here in NetBeans and I say, let's first just catch exception. And I don't know why this came here. There's no need. So for clarity, we had this. And if I said, yeah, but let's actually just catch exception, and then we'll just make a print statement. And we'll print this caused an exception. Let me even delete these. Gotta delete them and make sure I cut them out. Okay, so if I run this code, this is going to work just fine. Enter a month, they put 3, and it's just printing this caused an exception over and over and over because I forgot to put this in .next line. No harm, no foul. Okay, so let's do that again. This works just fine. I'm catching a very vanilla exception, a very pistachio exception, I said. We don't want to make fun of vanilla. This works just fine, right? I didn't catch the specific array index out of bounds. I catch something more generic, just exception, and that's fine. So here that worked. I could also come put a wrong value for the array. I can put here 81. That caused an exception. We put 8, and we're good to go. But what if we want to catch the very specific exceptions like this? Notice we have an error. Why is there an error? What does it actually say? Let's see if it makes sense. Yeah, exception input mismatch exception has already been caught. How's it already been caught? Because by catching exception, which is super generic, we basically caught all of the other exceptions and their subclasses. So if you want to put a superclass just as like a catch-all, that's okay, but it should come here at the bottom, right? So here you're saying catch specifically the input mismatch exception or specifically this array index out of bounds exception. If there's still some other exception, hell, just deal with it and catch any and everything, right? That's how that would work. Order matters. The finally clause, we're getting near the conclusion here. The finally clause is super helpful. It's going to be executed regardless of whether or not an exception was actually thrown. So sometimes you just want code to be executed regardless of whether or not you encountered an exception. Java has a finally clause to accomplish this objective, and this is the syntax. You have your try catch like normal, and then you have finally. And inside this finally block, we just have some final statements that are executed regardless of whether or not we had or we encountered an exception. So if no exception arises, the statements inside that finally block will be executed. If a statement causes an exception in the try block that is caught, then the rest of the statements in the try block are skipped, the catch block is executed, and the finally clause is then executed. The next statement after the finally is then executed as well. But what if one of the statements in the try block, what if it causes an exception that is not caught with a matching catch block, meaning that that exception is going to have to get thrown back to the caller method and the current method will be terminated. Even then, before terminating, the finally block is executed before passing that exception to the caller. So we can also rethrow exceptions. This is a lot. It's a lot of information. Hope people are taking notes. We can rethrow exceptions. Java allows that exception to be rethrown. So you can handle the exception a little bit maybe. So you can catch it. Even if you catch it and you handle it, you can still say, you know what? I handled my part, but maybe the one who called me also has something they want to handle, they want to do. And so even after catching it and performing some actions, you can then still throw it back to the caller. That's the idea of rethrowing. What we have now is just a simple example of tracing through a couple of program executions. Suppose there are no exceptions within this try statement. Well, we're going to do the try. There's no exceptions. We skip the catch. We go to the finally. We execute that. And then we execute the statements that come after that entire block. Or what if inside this try, pardon me, what if inside this try, we have this statement 2 that causes an exception of type exception 1. We catch that exception 1, we handle it, we then execute what's inside the finally block, and we come to the next statements. Or now, what if we have this statement 2 that causes an exception of type exception 2? We're going to skip this exception handler right here because it doesn't match. We come to exception 2, this exception handler. We have the code for handling the exception. That's all this handling EX is. Just whatever code handles the exception. And now we're going to throw that exception back to whoever called us. We've chosen to even throw it. But even before throwing it, we still have the finally statements. And now we throw it, and we will not execute this next statement. All right, we are almost done. Some cautions here. Exception handling is super valuable for the reasons already mentioned, separating the error detection from the handling of the error. But exception handling, it requires additional resources. It requires the instantiating, the creating of a new exception object, rolling back that call stack of methods open on the call stack, and propagating all of those errors to those calling methods. That's additional resources that are required for exception handling. When do you want to throw an exception? If an exception occurs in a method, if you want that exception to be handled by the caller, you should use exceptions. You should create an exception and throw it back and let the caller take care of it. But if you're able to handle the exception where it occurred in that method, maybe that method has the allowance to handle that exception, then you handle it right there in the method and you don't need to throw it on. Finally, when do you actually use exceptions? When should you use a try-catch block in your code? You use it to deal with unexpected error conditions. You do not use it to deal with expected or simple conditions. If we look at this example here, what if we just wanted to print a string? That simple. We want to print a string. Maybe that string has an actual value in it, or maybe it's a null object that was never actually created. We want to print a string. Maybe the object was not created, or maybe we assigned a string into it. We don't know. So we could use a try-catch and say, hey, let's try to print that string and then catch it if the string was null and was never actually assigned. That would be silly. That's an example of a silly, wasted set of resources to use try-catch just to print a string. Here, if you really needed to do that, it would have been better to use an if-else. We would say, hey, if this string reference variable, if it was actually null, then we're going to print its null, but if it was not null, print the string. There's no need to use a try-catch on something so trivial. Last slide. Caution simply is that exception handling is super, super useful, separating the detection of the errors from the handling of the error, allowing us to pass that exception back to whoever is most prepared to handle it and deal with that exception, right? To pass it back to the calling method. The caveat is that exception handling comes at a cost, so it's a judgment call. Should we handle it, or should we increase the resources and use exceptions and then throw them back? And we should only use this and create exceptions when dealing with unexpected error conditions. For simple errors, a basic if-else statement, more than sufficient. Let's go. We are done. It's been fun, but that's a lot. No exaggeration. That's a lot of content in only 33 minutes. So you may need to back up. You may need to refresh some of that, because what really follows is how do we incorporate this into programs, right? How do we practice that? But there's a lot of terminology. So as always, reach out, ask questions. It's been fun. Take care, everyone.